So on today's assignment right here on 3.4 WSP, I only want you to do 12, 15, 18, and 21. Of course, you could do all of them, right? The solutions are posted for you. But let's take a look at number 12, and let's work on this one together, right? If you want to just follow along and then try it later on your own, that's fine. But step one is to decide which variable you want to cancel. So you look at your x's. There's a 4, a 1, a 2. The y's 1, negative 4, 3. And the z's 5, negative 2, and negative 2. What do you think is the best option to cancel? X's, y's, or z's? X's, okay. So how do you want to cancel out x's? Which two equations do you want to use? Second and third, that works for me. Okay, so obviously the third one, if we want to cancel out x's, we're not going to do anything with that third one. I'm just going to rewrite it, 2x. Actually, let me rewrite it in black. 2x plus 3y minus 2z equals 21. And the middle one, since you guys told me to use the second and third one, I'm going to have to modify that one by multiplying by negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8y. Negative 2 times negative 2 is positive 4z. And negative 2 times negative 2 is positive 4. You guys with me so far? Yes. Okay. So we're going to combine the lines. The x's eliminate. 8 plus 3 is 11. We're talking about y's. 4 minus 2 is positive 2. We're talking about z's. And 4 plus 21 is 25. So, ladies and gentlemen, this is what we call new equation number 1. I usually box it in. I recommend you guys to do the same. New equation number 1. All right, so we've used the second and the third one. Let's go back and use the one we haven't used. That's step 2. Go back and use the one you haven't used. That first one, we haven't used it yet. So I need to use it. And if you read the steps carefully from that first page I gave you, it says use the one you haven't used and get the same variable to cancel. So the x is canceled. We need this x to cancel. All right? So I either use the middle one and change this to a negative 4, or use the bottom one and change this to a negative 4 to cancel with that positive 4. Again, step 2 is to go back and use the one you have not used. I haven't used that top one. I'm simply going to rewrite it right here. 4x plus y plus 5z equals negative 9. And we're going to manipulate, let's say, the third one by multiplying it by what? By negative 2. So I like drawing arrows and I like drawing notes to myself. As I'm drawing it down here, I want to put multiply by negative 2 and then draw an arrow that way. Okay, so I know that as I take this 2, I multiply it by negative 2 and that'll give me a negative 4x. I know that I take this 3, multiply it by negative 2, that'll give me a negative 6y. I know that I take that negative 2z, multiply it by negative 2, it'll give me a positive 4z. I know that I take the 21 and multiply it by negative 2, that'll give me a negative 42. And I did that because steps 2 said use the one you haven't used and get the same variable, in this case x, to cancel. So what do I have for my new equation number 2? I have positive 1 take away 6, that's a negative 5y. I have 5 plus 4, which is 9, talking about z's, and it is positive. And negative 42 plus negative 9, that's negative 51. And this is new equation number 2. So that was step 1 up here, new equation 1. Step 2, new equation number 2. And step 3, create your new 2x2 system. So here is my new 2x2 system. And that's simply putting both of those new equations together as a 2x2 system. So we have 11y plus 2z equals 25. We have negative 5y plus 9z equals negative 51. All I did was take this equation and take this equation, this one, and put them together as one 2x2 system. So now, what do you guys decide to do? What do you guys want to do here to solve this 2x2 system? Cancel out the y's or the z's? I would say z's, right? I'd rather deal with 18 and negative 18 as opposed to 55 and negative 55. So let's go with the z's. Let's multiply this by what? By 9 or negative 9. I want to go with 9, and I want to multiply the bottom one by negative 2. Okay? Again, we decided to cancel out z's. You could have canceled out y's if you wanted to. As I distribute the 9, I'll get this new equation. 99y plus 18z equals 9 times 25. What is that? Anybody? Calculator? 225. Thank you. And on the bottom one, negative 2 times negative 5 is positive 10y. Wow, this is ugly. Positive negative 2 times negative 9 is negative 18z. And negative 2 times negative 51 is positive 101. Yay? 102. Just checking to see if you're paying attention. Just kidding, I messed up. Yeah, 102, thank you. So now we are able to combine the lines. The z's cancel. We end up with 109 y equals, dang, 327. That is ugly. I really, really hope that when we divide by 109, we get something nice. Do we? Yeah. 3. Yes. Thank goodness. Y equals 3. Now, if I would have gotten a crazy decimal, I'd probably go back and check my work. But since it did end up being a nice, beautiful number 3, that's great. Let's continue. Take that 3, plug it back into any of the 2 equations of your 2x2 system. I want to use the bottom one, I guess. The bottom one, I'm going to rewrite it. It says negative 5y plus 9z equals negative 51. All I did was rewrite this guy. And I put a parenthesis in place of y. I put the parenthesis because I know I'm going to plug in the y value of 3 right in there. Whoops, I went over my 51. Sorry about that. So anyway, what do we have here? We have negative 15 plus 9z equals negative 51. Let's solve this thing. Adding 15. We end up with 9z equaling, anybody? Calculator? So I can be safe. 36. Negative 36, right? And we're going to divide by 9. Divide by 9. We end up with z equals negative 4. There are no room for errors, right? If we would have messed up on one little negative sign, it'd all be done. Anyway, we now have our answer to our new 2x2 system. And if you do go back to the steps that I originally gave you, you simply take those 2 answers and plug them back to the original, any one you want. So which one would you like to do? The top, the middle, or the bottom? Top. Top? Okay. So the top one, I want to rewrite it over here. Top one is 4x. Let me zoom in a bit. You could plug it into any one you want, but you guys told me top, so here I go. 4x. Now, I don't know x, so I actually write x. Plus y. I do know y. Y is 3. I don't even really need it in parentheses. Plus 5z. We know z is negative 4. Equals negative 9. Equals negative 9. Again, I just took this top equation, rewrote it, but instead of y's and z's, I put my y right there and my z over there, right? And I plugged it in with parentheses, even though it's not necessary on this one. So let's make this equation look nicer. Let me zoom in, make it look nicer. I have the 4x, and I have a 3 right here, and I have a negative 20 right there. 5 times negative 4 is negative 20, equals a negative 9. When I combine the like terms, 3 and negative 20 is negative 16. So I have 4x, no, minus 17, I'm sorry. Minus 17 equals negative 9. Add 17 here. Add 17 there. We end up with 4x equaling 8. Final step would be to divide by 4. Divide by 4. And we get our answer, x equals 2. So look at all that work. That took about half of my notebook page. Anyway, our ordered triple, our answer, our ordered triple is x is 2, comma, y is 3, comma, negative 4. That's right, 2, 3, negative 4 is correct. That's your answer. And of course, you could triple check this by plugging in each of them, right? 2 right here, that would give you 8. 8 plus, plug in 3. 8 plus 3 is 11. Plug in negative 4 right there, that's negative 20. 11 plus negative 20, that will give you a negative 9. Plug in 2 right there, plug in 3 right there. That would be 2 minus 12. That'd be negative 10. So remember, negative 10 minus 2 times negative 4, that's plus 8. Negative 10 plus 8, that is negative 2. Plug in 2 right there, that's 4. 3 right there is 9. 4 plus 9 is 13. 13 minus 2 times negative 4. 13 minus a negative, that's a positive 8. 13 plus 8 is 21. So it does work. I do not recommend you guys do this in your head the way I did. I recommend using a calculator, plugging in the 2, writing down the number 8, plugging in the 3, doing 8 plus 3 with the calculator and all that stuff so you could verify all 3 of them. But you will be absolutely correct. If you check it, you'll see that you get it right. And that's it. That's the explanation of this problem. So we have number 15 right here. Let's get a variable to cancel. Let's look at the x's, look at the y's, look at the z's. What do you think's easiest to cancel out? X's, y's, or z's? X's? Okay, x's, sure. I would have probably gone with z's, but let's go with x's because you guys said x's, I'm going with x's, all right? So if I want to cancel out x's, I would probably take the top equation and leave it exactly the way it is. So that's what I'm going to do. 3x plus 3y plus z equals 10. But to cancel out x's, I'm going to have to take this bottom one and multiply it by negative 1. And I would get it right here. Notice that I like drawing arrows. It keeps me organized. Negative 3x plus 2y minus 3z equals positive 9. And when I combine the lines, we cancel out the x's that you guys wanted me to cancel. Like I said, I probably would have gone with z's. I'm going with x's because you guys told me to. What do I end up with? I have a 5y, a minus 2z, and also an equals 19. And this is our new equation number 1. New equation number 1. All right, so step 2, if you have those steps in front of you, is to go back to the original and use the one you have not used. And it also says get the same variable to cancel. So we use the first and the third. We have not used the second. Let's use that second and get the same variable to cancel. Now notice the x that I want to disappear is a 5x. So I need to actually use another equation and this one and get them to cancel. And the only way that happens is if they're exact opposite values. That would have been nice if this was a 6x. Then I would just have to multiply this by negative 2. But it's not a 6x, it's a 5x. And 3 and 5, you're going to have to actually modify both equations to get a positive 15 right here and a negative 15 up there, or vice versa. Does that make sense? So if I need the x's to cancel, I am going to have to take the one I have not used, and I'm going to simply draw an arrow and then put multiply by 3. So I'm going to multiply it by 3. 5 times 3 is 15 with an x. 2 times 3 is 6 with the y. 2 times z is 6 with the z. And 7 times 3 is equal to 21 over there. 21. Now I'm going to take the top equation and I'm going to multiply that by negative 5. So multiply by negative 5. So 3 times negative 5 is negative 15x. 3 times negative 3 is negative 9. Or no, I'm sorry. 3 times negative 5 is negative 15. Y. 1z times negative 5 is negative 5z. And 10 times negative 5 is negative 50. So now we could combine these guys and eliminate that same variable x. So we end up with negative 9y, a positive 1z, you don't even need to put the 1, equals negative 29. Yay? Okay. Ahora sí. So let's create our new 2x2 system. So your new 2 by 2. It's going to be right here. I'm simply going to put them together. 5y minus 2z equals 19. Negative 9y plus 1z equals negative 29. So this is our new 2 by 2 system. We could focus in on this 2 by 2 system and solve it. What do you guys want to do? Cancel y's or z's? Z's are definitely easier. Actually, I'm not even going to mess with the top one. The bottom one, we will multiply by 2. So we end up with negative 18y plus 2z equaling negative 58. The top one's going to stay the same. 5y minus 2z equals 19. Now we could combine those lines, eliminate the z's. We end up with negative 13y equaling, what is that? Negative, help me. Calculator? Just so we could be safe here. I don't want to make another mistake. Negative 39. Thank you. And final step would be to divide by negative 13. Divided by negative 13. That does give us y equals positive 3. So we have the y value of our 2 by 2 system. We still need the z value of our 2 by 2 system. So let's plug it back into the top one. The top one, rewriting it, is saying 5y minus 2z equals 19. And notice that I put parentheses instead of y because I already know that y equals 3. So I'm going to plug in a 3 right there. And I'll have a new equation that reads 15 minus 2z equals 19. Subtract 15, subtract 15. You'll end up with negative 2z equaling 4. Final step would be to divide by negative 2. Divide by negative 2, giving you z equals negative 2. So we have our answers to the 2 by 2. And if you were following those steps on that piece of paper, you would substitute both of those answers back into any original equation. Which one do you guys like to use, the top, the middle, or the bottom? Top one, okay. The top one reads 3x. Do I have the x? No. So I'm just going to write 3x. And then plus 3y. Do I have the y? Yes, I do. So I'm going to put 3 parentheses. Do I have the z? Yes, I do. I'm going to put parentheses. And then equals 10. That's what the top equation says. All I did was rewrite it, but instead of the y and the z, I put parentheses right here. Now let's actually plug in those values. The y value is 3, and the z value is negative 2. So we're going to simplify this. We're going to have the equation 3x plus 9 minus 2 equals 10. And of course the 9 minus 2, that'll give you 7. So what we really have here is 3x plus 7 equals 10. We're going to subtract 7. We will end up with 3x equaling 3, giving us a final answer of 1. So x equals 1. So our ordered triple is 1, negative 2, positive 3. So the answer that you're going to type in is 1, comma, 3, negative 2. Sorry, it has to be in order, x, y, and z. That's why it's called an ordered triple, x, y, and z. So that's our answer. If you want to be absolutely positive that that's your correct answer, you should plug them in to all 3 equations and verify that it actually gives you a true statement. So I plug in a 1 right there, that's 3. Plug in a 3 right there, that's 9. 3 plus 9 is 12. 12, plug in a negative 2. 12 take away 2, that is 10. Again, I don't recommend doing this in your head. I would actually write it out on paper with the calculator to verify. Plug in a 1 right there, that's 5. Plug in a 3 right there, that's 6. 5 plus 6 is 11. Plug in a negative 2 right there, that's 2 times negative 2, that's negative 4. 11 plus negative 4 really is 7. Plug in a 1 right there, that's 3. Plug in a 3 right there, that's negative 6. 3 minus 6 is negative 3. Plug in a negative 2 right there, that's negative 6. Negative 3 plus negative 6, that really is negative 9. So we have triple checked. It works for all three equations. We're absolutely positive that that's a correct ordered triple. And look at all that work that it took. Very important that we actually practice this, right? You could understand this, but if you're not practicing, you're not going to get it. So this is number 18 from today's assignment. A lot of people might freak out with this one because it's not organized. So we need to get it organized, right? We don't want U's and V's on the right side of this thing. So I would start by, what the heck? U's and V's and there's X, Y's, and Z's? That's just all messed up. Okay, that's not going to work. I am assuming that the publishers on the worksheet made a mistake. I'm assuming that the minus U and minus V should not be there. Okay? So if we said, I want to cancel out X's because they're ready to go, right? When you combine, when you rewrite the top one, X minus 2Y plus Z equals -1, and you do the middle one, negative X plus 2Y minus Z equals 6, and we combine and cancel to get our new equation number 1, everything cancels, so you get 0 equals 5, and we know that that's not possible. That's a no solution. So no solutions are awesome, but you know what? Yeah, this thing, that thing, that's just not supposed to be there, okay? All right, 21 is a special case problem. If you guys wanted to see a special case problem, let's do this one. What would you guys like to cancel, X's, Y's, or Z's?
Y. Yeah, Y.
So Y's are good, but then again, Z's are pretty easy as well, right? Well, the goal is to cancel out one, but it might happen where more than one cancel, and then that might be a special case problem. You know what, guys? I want to take this opportunity to show you that not only could you multiply an equation to modify it, but you could also divide an equation to modify it. I know that sounds weird, but if we take a look at this middle equation, I just noticed that all of these are even numbers, right? So if I wanted to, I could take this middle equation and I could divide it by 2, divide everything by 2. Now, this is cool because we've never done this before. So when I divide everything by 2, I'll have a negative 2x, I'll have a positive 5y, I'll have a positive 1z, and I'll have a positive 3. I know that looks weird, but now it's actually ready to combine with the top equation, isn't it? So I have 2x minus 5y minus 3z equals 7. And now we could actually combine the lines, and the x's also cancel. So we end up with a negative 2z equaling 10. And then divide by negative 2, divide by negative 2, we'd get z equals -5. Yay? Yeah. All right, so normally we would have a new equation number 1 that has 2 variables, right? The whole purpose of following those steps is to get a 2-by-2 system. So again, we normally want a new equation number 1 that has 2 variables only, but right here we got something even better. We have one answer, all right? We have z equaling -5. So I could use this answer, -5 for z, and I have to use the one I have not used. The one I haven't used is the bottom one, the third one. I want to rewrite it, 6x minus 15y. Now, minus z, I already know that z is -5. So minus -5, right in here, equals -19. Now, I know you're thinking, well, what's that for? Well, when I plug in the z, what ends up happening is I now have an equation that only has x's and y's, no more z's. And that's what we want in the first place. We want a 2-by-2 system that only has 2 variables. So right here, this changes. I end up with 6x minus 15y plus 5 equals -19. You're going to subtract 5 to clean it up a bit. We will have 6x minus 15y equaling -24. And this is a equation that only has x's and y's. And that came from the third one. So we have used all three of them. I need another equation that only has x's and y's, and I could also do that by plugging in the z value of -5 in either to the first one or the second one. So it doesn't matter which one you want to use. Which one would you like to use, the top one or the middle one? Let's go for top. The number is a little bit nicer. So I want to take that -5 and I want to plug it right in there. Okay. So here goes, let me just write it new down here. It's a 2x minus 5y minus 3 times -5 equals 7. And now let's simplify this. We're going to have 2x minus 5y plus 15 equals 7. Minus 15 minus 15. That'll give us a 2x minus 5y equals -8. Yay? And this is another equation that only has x's and y's, kind of like this other one that we have. So we technically have our new equation number 1, we have our new equation number 2, and we could now do our new 2x2 system. So the new 2x2 will be 6x minus 15y equals -24. We have 2x minus 5y equals -8. Oh, okay. All right. Yeah, so we could divide this guy by -3. Now, if this is throwing some people off, you don't have to do that, right? You could.
It's the same thing.
It's the same thing. Yeah, it's the same thing. Many roads to the same place, right? You could simply multiply this whole equation by -3. So it's up to you if you want to multiply by -3 or if you want to divide by -3. What do you guys say?
I think it's the same.
You want to divide?
Multiply.
Multiply might be a little more understanding for people. All right, let's multiply. Multiply by -3. But you could divide if you want. So up on top, we end up with the same exact equation. It would have definitely been easier to divide. On the bottom, distribute that -3, that's -6x plus 15y equals +24. Combine, cancels, 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 0 equals 0. What do we say? Infinitely many solutions, IMS. Which I believe on the test, you don't even have to put the decimals. You just put IMS and you're good to go. That one took a while. I'm sure it could have been done 1,000 other different ways, but that's how we got it.